The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, good morning, good evening to all of you, wherever you are. This is Krishna Vedula from IUC, and we have with us our friends from MATLAB. Spandana is going to be the one presenting today on this exciting topic of IoT applications using MATLAB and ThingSpeak. So over to you, Spandana. It's all yours.
Thank you, Professor Vedula, for your kind introduction. Hi, everyone. Today's webinar is brought to you by MathWorks, and the topic is enabling Internet of Things applications using MATLAB and ThingSpeak. So at the end of this webinar, I would like you to keep in mind 3 points. But before that, I'll introduce myself. My name is Spandana, and I work as an education technical evangelist at MathWorks. Predominantly, my team works with faculty and researchers all over India to help them use MATLAB and Simulink in their courses and research. I have with me my colleague Naini here. She also works as an education technical evangelist, and you'll see her interrupting me to ask questions and to understand more about how IoT applications can be built using MATLAB and ThingSpeak. So at the end of this webinar, I want you to keep in mind these 3 key takeaways. That is, IoT is a mega trend, and we'll see why it is getting there. And also, getting started with IoT is very easy with MATLAB, Simulink, and ThingSpeak. And MATLAB and Simulink are traditional platforms which you are probably already aware of. I'll explain to you what ThingSpeak is in the next couple of slides. And MathWorks sort of provides end-to-end capabilities for the entire IoT workflow, all the way from getting data from your devices such as Android, Arduino, Raspberry Pi, processing it in MATLAB, and posting this data onto a web service known as ThingSpeak. Today's agenda, we'll see what is Internet of Things, and we'll try to understand why is it important, what can be done in the space of Internet of Things, and we'll also see how to interface Android devices, specifically Android devices with MATLAB, and we'll see how MATLAB and ThingSpeak are integrated and how they work together and enable IoT applications. And we'll see how MATLAB Analytics is built in ThingSpeak directly, and what can be done in the environment of ThingSpeak using MATLAB. So first question, what is Internet of Things? So in the last 20 years, we've seen exponential increase in the number of connected devices. Loosely speaking, Internet of Things is nothing but things that are getting connected to the internet. It's not so simple, but there is a lot of work that is going on in the back end in terms of what APIs are being designed, what infrastructure is being designed, how the servers are set up, and so on, to enable this kind of communication between devices. If you've observed in, I think, 2010, smartphones were just coming in, and the best example of IoT we had at that point was maybe our Google Maps, right? So we could see how traffic in a certain region would increase or decrease, or what is the state of traffic in a particular region. But nowadays, your phone can communicate with, for example, Alexa to control your home environment and the appliances in your home. And these devices can communicate with each other to perform certain tasks. And this communication is enabled through the platform or through the technology known as Internet of Things. So over the years, I think by 2025, we'll be interacting with almost a lot of every consumer will be interacting with as many as 50 smart devices. For example, your smart home's wake-up service might combine lights, healthcare sensors, maybe switch on the news summary, and also your coffee machine. So this is something that we've sort of read only in the science fiction novels before, but this is becoming a reality. At one extreme, these things will deliver simple experiences like, say, switching on a colored LED based on your mood or based on brightness of your outside environment, or emit a simple sound. And on the other extreme, interactions will become technically complex with multiple devices collaborating with each other to provide a service or to deliver a value. For example, smart shops, for example, can bill your bills automatically as and when you pick up an item, and smart offices and smart cities are being built, which can enable these smart spaces where you have very high energy efficiency based on by monitoring how many people are in that environment. And already we have devices like Apple Watch and Fitbit devices which sort of provide smart healthcare um, data. And one area where IoT is making a significant impact is in the area of logistics, where for example, your Amazon order that is coming to you, being delivered by Amazon, it's being tracked through the technology of IoT, where it is, when will it reach you, and so on. And all these analytics can be provided in a very efficient and effective manner. In future, we might have clothes which might transmit data regarding temperature and humidity, and communicate with your devices to monitor your health and so on. And we already have home devices such as lights which can communicate with your Alexa. Similarly, you can switch on a washing machine at a predetermined time or switch on your AC just before you enter the house. And all these applications are going to increase in future, and for all this, we need technology to enable this, and this is known as IoT. Collectively, basically, our things are transmitting data, and we need to analyze that data to find out what insights we can gain from them so as to take an action. And how can this be done? And this is why IoT is important. So let's see what kind of applications IoT can deliver. So I live in Bangalore, and the civic management system here is quite poor. For example, so every day, garbage pickup person comes to my house and picks up the trash from my home. And this is quite an inefficient manner of picking up garbage. So what can we learn from a city of Boston and how they manage their trash problem? So basically, the city of Boston has these smart dustbins where every dustbin sort of caters to about 10 to 15 houses, and as and when the dustbin becomes full, it sort of sends out a signal to the civic management system there, the authority there, to say that the dustbin is now full. So using this data, the municipal corporation in Boston can sort of analyze the trends in terms of like what is the most optimum way of picking up trash and how many dustbins get full at what time, and this way they can sort of reduce thousands of dollars a year by picking up the trash when it's full.
So I have a question, Ms. Vandana. So how are they actually capturing the data? What is the input to this particular system?
So good question, Naini. So first thing we need is a sensor, right? Like the trash bin here should have a sensor to sort of find out when it becomes full. So for example, if there is a sensor on top of the dustbin here, and it can monitor when the trash is full, and it can communicate, or it is connected to the internet and can communicate and send out the data saying it's now full, and the timestamp when it is full, the municipal corporation receives that data to perform their analytics. So we know that every industry is sort of moving towards IoT. So let's see one real world example of what one particular industry is doing using this technology. So this is an example of Cadmus. Cadmus is an energy management solution consulting firm, and they were faced with a very difficult challenge. That was to measure energy efficiency of the residential homes And typically this was done using sensors which were placed in homes, and these sensors collected data over long periods, and they were not sort of connected to the internet, so they were just logging data. And after 6 months, when people went to get the sensors to retrieve the data, many of them found that these sensors were broken, or they did not collect the data properly, or the battery ran out, and many such problems. So what they did was Cadmus sort of used ThingSpeak to collect up to the minute temperature, humidity, and power usage data to perform data analysis, algorithm development, and model it, and also used machine learning models to better predict what the energy requirements of those homes were. So how did they do this? Um, they deployed sensors which could directly sort of connect to the internet and transmit data to the net. And they used MATLAB analytics on ThingSpeak environment to analyze this data and visualize them and also make predictions. And the result was that they could quickly deploy their sensor networks, which in turn cut their development time by 2/3. And instead of having to set up servers and build this entire infrastructure all the way from scratch, they sort of seized the opportunity as the first mover. A few other examples where a certain companies, what they did was they could predict the load, that is the energy requirement of the next day, as in by studying the past data of how energy consumption was, they could predict what accurately what the next on the next day what the load requirement would be like. And for this, they had to collect data from multiple sources, clean it, and build a predictive model to make such a prediction. And also they had to deploy this into a production environment. And again, there are many logistics companies which are using this technology, and also smart watches. This is one example by a research group where they sort of placed a mobile phone on the waist of a person, and they collected data for various tasks, such as the sensor data that when a person was lying down or was just standing, sitting, climbing down the stairs or up the stairs, or just walking on a plain surface. By collecting all this data, they could sort of understand what the data meant by performing feature extraction and classification using machine learning techniques. And all these examples are available in these links here. And another example was built in our MathWorks office to monitor traffic. So this is a webcam which could directly be interfaced through MATLAB to check the traffic on the road outside our office to see when the peak traffic movement was. So basically, to enable all these applications, we need a predefined workflow. So let's see what the workflow for IoT is. First and foremost, we need smart connected devices. So these devices could be phone, Android or iOS phones, which can act as both sensors as well as transmitters, or Arduino devices which have Wi-Fi modules attached and sensors, for example, temperature or humidity, measurement temperature, and so on. And these devices or these platforms can send out signals to the data aggregator, that is the server or cloud. And the data from the server can be read either in the desktop environment or can be read in the cloud. So let's see how MATLAB sort of provides capabilities for all these steps. So for smart connected devices, we have hardware connectivity with Simulink, with all Arduino as well as Raspberry Pi, as well as Android and iOS devices, and Lego and plenty other devices. And for our cloud platform, we have ThingSpeak. ThingSpeak, I think, was basically ThingsSpeak, and which became ThingSpeak. And we have MATLAB on both ThingSpeak as well as MATLAB in desktop environment, which can communicate with ThingSpeak. So the first step, as I said, was to configure our devices with MATLAB or with MATLAB and Simulink. So I'll give you a demo now. This demo is about building a step counter. And basically what we're doing is you must have seen plenty of apps which if you carry your phone, they can tell how many steps you walked. So we're going to build one such app where we are going to use our Android phone to walk with it and find out the number of steps we've taken. So how do we do that? We are going to use the accelerometer sensor on our Android phone, and we're going to analyze the accelerometer data in MATLAB. That means we need to interface our MATLAB with our Android phone, right? So the step one is to configure hardware connectivity between Android and MATLAB desktop. For this particular example, we'll need a signal processing toolbox as well as Simulink support package for Android devices. This can be gotten from add-on support packages. I'll show you where that is, and a list of other things. And these will be in the PPT, which will be shared later. So the first step to set up our Android device and to set up the communication between our Android device and our laptop, we will write a command known as Android HW setup, that is Android hardware setup, in our command window. So this is how it will look like. The moment you call Android HW setup, you will open a hardware setup dialog box where you can first download Android Studio. Just follow the instructions step by step, and at every point click the verify button to see if the instructions have been followed correctly. You will have to install the Android software development kit and also enable the developer option on your Android device. And the instructions for all this is clearly enabled in a step-by-step workflow, which you can follow in using this video here. So here I'll be using 1+3 device. So I'm choosing different device, which is neither Samsung nor Google device. And we are going to see interface this 1+3 device. So if your device is properly configured, you should be able to see the device name in this dialog box here. And remember that your device as well as your laptop should both be on the same Wi-Fi network. And once this is all the network is established, MATLAB will sort of build a test app on your mobile device and run it and test the connection. So this is the process where the test app is being run on my phone. And once the setup is complete, you will have access to stream mobile sensor data from MATLAB from your phone to MATLAB. So for that, we need another interface on your mobile device, right? For that, we need something known as MATLAB Mobile. So we have MATLAB Mobile app, which can be downloaded from Google Play Store or from Apple equivalent Play Store. So in MATLAB Mobile app, you have a section where you can either perform basic computation such as basic arithmetic in your command window. Also, you can enable certain sensors. Here we have sensors for accelerometer, magnetic field, gyroscope, angular velocity, and GPS. And all this data can be either streamed into MATLAB or or you can make a log file and store on your MATLAB drive. So when you sign in and download this MATLAB mobile app, you will have to connect to MathWorks Cloud. For this, you will need a mathworks.com account and with a valid license to access both MATLAB Drive as well as MATLAB mobile app, and also ThingSpeak. The third step is now we've sort of interfaced our phone with MATLAB. The third step would be to post results into ThingSpeak. So what is ThingSpeak? ThingSpeak is a cloud platform, and it's an open IoT platform which a lot of hobbyists use for prototyping and for sort of basic studies or basic data analytics in IoT. So ThingSpeak is a service where you can either send your sensor data to the cloud and also perform analysis and visualizations on the cloud. And you can also trigger reactions, like maybe sending an SMS through an SMS web service, or you can post on your Twitter channels and so on. So basically, ThingSpeak is it uses popular IoT protocols, and it can easily configure hardware devices, and you can send your sensor data in real time. Also, all the sensor data that is aggregated from other sources. That means if your friend or someone else who has created ThingSpeak uh, channels, what they can do is you can access their data and also perform analysis on their data. And you can use the power of MATLAB to make sense of your IoT data. MATLAB is a powerful environment for data analysis and visualization, and you have entire MATLAB analytics available in ThingSpeak. You can also run your IoT analytics automatically. That means you can schedule execution of a code, of a particular section of code, um, at a particular time. For example, every 1 hour you can run some code to get some analysis, and you can also communicate it to other third-party services like Twitter. This way you can prototype and build your IoT systems without having to set up any server or develop specific web software.
I have another question, Spandana here. So can we use a MathWorks account to sign into ThingSpeak?
Yes, you have to use your MathWorks account to sign into ThingSpeak, and your MathWorks account should have a license to access ThingSpeak.
Okay, I have another question. So the data that I post on ThingSpeak, is it like public or a private data?
You can choose to configure your data either in a public manner or on a private channel. So you can choose how you want to show your data on ThingSpeak. So basically, did I answer your question, Ning?
Yeah, thank you.
So the core concepts of ThingSpeak is basically there is something known as channel, and that channel is a place which you can store data and also retrieve from that channel. And every channel has a unique number assigned, and that is called channel ID. And if you choose to keep your channel public, we will have you won't require an API key to read information from the channel. But if you want to write information into a channel, we will have a specific API key. So again, as I said to Naini just now, that the channels can be configured to be either public or private. And also we have plenty of apps on ThingSpeak to add on as add-on functionalities. So I'll show what all apps are available and what can be done in our next demo. So as I said, we'll be building a step counter in this demo, and we'll be getting data from our phone. This is accelerometer data from our phone, and we will use that data to build a step counter. So here I have a MATLAB code for building the step counter demo. Here I have opened what is known as MATLAB live script. So if you're not familiar with this interface, you can go to home and create new live script. Unlike typical MATLAB scripts which have .m extensions, live scripts have .mlx extension, and they are just like best of both worlds of MS Word, where you have good formatting, good RTF, rich text formatting environment, along with an executable section of code. So we can configure and also divide them into sections and write our snippets of code with a lot more information on what that particular snippet does. So this is the environment of LiveScript, and if you were not earlier aware, you can go here to this, where my mouse is being pointed at, to this section to create a new LiveScript, and it executes exactly like your MATLAB code, except for the comments and other section which are just the text, which can be sort of written in a much more beautiful manner. So in this section, first we are going to start our mobile tracker, So here we are creating a mobile development object to start our tracker. So just to prevent any connectivity issues, what I've done here is I've sort of streamed data and created a log file which is present here as a .mat file. That is, my accelerometer data is not being real time sent into MATLAB, but instead I have created a log file and I've saved it here just so that there are no any connectivity issues. So here we've created, I'll just clear my workspace and my command window using clear all command, and we are going to run this section of code where we are first creating a mobile dev object and starting our tracker. So here we can see that our activity tracker is now started, and the second step we are going to find out the acceleration. So here I'm loading my data from my log file, but you can also stream data in real time. So here I've sort of switched on my activity tracker to obtain acceleration data. If you see, this acceleration data is a variable known as timetable data type. In MATLAB, timetable data type is nothing but a data type which has a timestamp. Timestamp is in the format of date, month, and year, along with hour, minute, second. And we have XYZ acceleration, the of like 3-axis acceleration data available here, and we are reading the XYZ acceleration and creating new variables X, Y, and Z for that particular acceleration data, and we are going to compute the magnitude because the magnitude gives us more information of the acceleration than any individual component itself. So the magnitude is being computed as a square root of sum of x square plus y square plus z square. And if you observe this, we have plotted the raw data, and you can see that our acceleration data is sort of like all the peaks are almost averaging near 10, right? So do you get a hint, Nani? What is happening here?
So maybe the acceleration due to gravity, which is 9.8, the value, and because of that, it's coming around 10.
Okay, this is awesome. So she's picked it up very fast. So what's happening here is we are getting our acceleration. We are actually picking up our acceleration due to gravity as the baseline. So we have almost all our peaks surrounding around 10 meter per second square. So if you want to subtract our baseline, we are going to subtract our mean magnitude from the magnitude we just computed. And we're going to plot this new set of data, which should sort of surround 0. And now we have our new acceleration data where we've removed the effect of acceleration due to gravity. Now, if you want to compute the number of peaks here, we are going to use our signal processing toolbox and the find peaks function in the signal processing toolbox. But there is a catch here, like is this step counter app going to work for every person? If I ask this question, the answer may not be, because an old person's walking style would be very different from a very young person's, right? So the peak height would be sort of more apart, for example, or maybe if you're walking on a rough surface, your walking pattern would be very different. So when you are going to write your own application, you have to design the algorithm such that you're actually getting the correct number of steps. So here what I'm doing in my algorithm, I'm choosing a threshold which is 2.5, which I calculated roughly for my example here, saying that any peak which is above 2.5 and which looks like a peak will be picked up as one step. So this is a very primitive way of designing an algorithm for building an app like step counter. But if you want to be more accurate, you will have to design a much more rigorous algorithm with also including information regarding peak distance and peak to peak height variations and so on. So here we're going to use the find peaks function to find the number of peaks in this particular data. So we are using signal processing toolbox to find the peaks and their location. and we are computing the number of peaks as number of steps. So in this particular example, I am finding that my number of steps are 26. So if I plot my data now along with the peaks that have been computed, you can see that the red triangles here are the peaks that are being calculated. So if you want to make it more rigorous and also remove more outliers, what you can do is you can compute the distance between these triangles and design your algorithm accordingly. So here so far what we've done, we've gotten our data from our Android device. We have done a basic MATLAB pre-processing, that is removing the acceleration due to gravity, and then we did some post-processing, that is we calculated the number of steps. Now the next step is, if I want to build an activity tracker and I want to send this information of my number of steps and I want it to be available at any time, anywhere. So this number has to be posted somewhere. So that platform is ThingSpeak. And we are going to post that using our code where we are going to write this data into our ThingSpeak channel. At this point, let's go into ThingSpeak and see how ThingSpeak looks like. So just give me a moment. I'll open ThingSpeak. So this is our ThingSpeak environment, and you will have to sign in using your mathworks.com account. So here I have already signed in using my mathworks.com account, and I've created a channel for today, which is known as IUCEE Step Counter. So let's see what this channel has. So every ThingSpeak channel, when you're creating it, you can set up your channel like this, where every channel has a channel ID. Here I have a number that is assigned for my channel, and the name of this channel is today's example, which is IUCE Step Counter, a basic description about it. And these fields are nothing but the fields that will reflect or the y-axis on your graphs that will be shown on your ThingSpeak web page. So here I'm computing two things. One is number of steps that I'm taking. That means that is the absolute number of steps. And then another field is the cumulative number of steps. So if I repeat my exercise again, it basically sort of adds on to my previous number of steps. And then we have other other preference settings as well, where you want to, if you want to either link it to GitHub and so on, and then you press save channel. So here you can see that this is my channel statistics, and you can also see that there are two tabs here. One is to perform MATLAB analysis in ThingSpeak, and another is to create MATLAB visualizations. And we also have a pretty good way of either displaying knobs, dials, displays, and so on. So I'll show you how all this can be done. So if you want to add a visualization, so you click on add visualization. Sorry. Here we go to add widget. And if you want to say have a numeric display displayed, which I have here, then you go and click this and show next. What do you want to display? Do you want to display your field 1 or field 2? Here, if I want to display field 2, which is my cumulative number of steps that I've taken, so I've given the name as cumulative steps, and I'm displaying my field 2, and I'm creating a new visualization. So here you can see, since 4 hours, I've walked only 51 steps, which is quite bad. So let's see what else we can do here. So in my this channel is private channel, so you can see that here. It's the access is limited as private, and in channel settings you can get the information about channel ID, and in the section of API keys you'll have two keys, which are the write API key and the read API key, and these specific keys should this exact same key should go into your MATLAB script if you want to post any activity on ThingSpeak. So let's go back to our MATLAB and post our activity of 26 steps again. So first thing, we need to access this URL. So we are going to access the URL of thingspeak.com, specify the correct channel ID and the correct API keys, that is the read API key and the write API key. So I've already sort of taken these API keys from my ThingSpeak, and I'm going to execute this section of code. And I'm going to hope that my activity is posted. So if I go back to my ThingSpeak, I should be able to see a new activity posted. So you can see at about 4 p.m. 16, we have a new activity that is posted on our cumulative counter and our absolute counter. So this is how ThingSpeak works. If you have any questions, you can also feel free to write them down in the chat window available on the webinar panel.
Yeah, let's encourage them. Yeah, all of you participants, you got about 65 of you, so please put down your questions in the chat window. We'll be more than happy to answer them. Okay. Maybe we can just wait for a couple of minutes and give them a chance to think through it.
Okay, sure.
Yeah.
We also have in ThingSpeak, we also have options to import and export data where you can sort of directly get CSV files imported into ThingSpeak if you're not going to say stream the data into ThingSpeak. And we also have MATLAB analytics, like I said. So let's see what we can do here. So in MATLAB analysis page, you can either create a template, you can create a template to get data from private channel or a public channel or from web page. That means you can get, you can scour web pages and get data. And there are plenty of examples here that you can try out. These are using existing channels and existing like free public channels, so you can always try out these examples. Then now let's go to the apps section here and see what all we can do here. So in apps, you can see we have MATLAB analysis. This is the section where you can sort of explore your data and do some pre-processing in the ThingSpeak environment using MATLAB. The code and the semantics are the same like MATLAB. You can perform MATLAB visualizations, that is plot graphs, create maps, and so on. And you also have MATLAB plugins like gauges, charts, or other type of custom plugins. You can take actions by ThingTweet. That means, say for example, there is an example where we have set up a weather station, and when the humidity goes beyond a certain level, you can tweet that the humidity has surpassed this range and it might rain today. Similarly, you have something known as time control. Time control is where you can automatically perform execution. You can execute certain code in a time control manner, like either 1 hour once a certain section of the code gets executed. And you can also react. That means when a channel data, say, meets certain conditions, you can trigger a response either in terms of, say, a webinar, an SMS or something. Also, Simulink also has a ThingSpeak icon where you can write and read. This is the Simulink library browser I have here. So we have, if you have downloaded Android Simulink support package for Android devices, you have ThingSpeak read and ThingSpeak write blocks. So you can directly read ThingSpeak data or write into ThingSpeak using these blocks. Nani, do you want to add anything?
There's a question from the audience. Murugananthan, do you want to ask the question yourself? I'm unmuted you. You have a mic? Murugananthan, come in. Okay, the question, yeah, come in, Murugananthan, yeah. You're coming in.
Hello.
Yeah, go ahead, yeah, ask the question.
Yeah, is there any possibility to developing a blockchain by using this MATLAB related to the IoT?
Regarding blockchain and MATLAB, is it?
Yeah.
So blockchain is a totally different platform, and for say building or implementing, we have one example on the MATLAB file exchange for blockchain. So this is something that you can check out, and we will post the link on the chat window here. And you can sort of distribute, you can build nodes to run and distribute the blockchain and blocks using that example. But specifically from MathWorks, we don't have any blockchain tools available from MathWorks end. This is a third-party developed and posted on our file exchange, which we can share with you. Is this information useful?
Yeah, okay, thank you.
Okay, another question.
I'll be posting the link to the blockchain example here on the chat window soon.
Okay, so another question from Ansi Sarah Varghese is, can we have a MATLAB application for IoT based app? Let's see, can we make a MATLAB app for IoT based application using ThingSpeak? Ansi, do you want to unmute yourself and ask a question yourself? If you can, otherwise I read it out. Do you understand the question? Can we make a MATLAB app for IoT based applications using ThingSpeak platform? Does that make sense? I don't know. Ansi, come in. I'm unmuted you. You want to clarify your question? Okay. How do you deal? Hemant is asking, how do you deal with large volumes of data storage, since it may evolve into big data? Example, smart meter data.
Okay. Especially, thank you for your question, sir. So with regards to big data, of course, we have something known as data stores in MATLAB, which can handle big data. So this data store, and we also have something known as tall arrays, which can sort of make use of.
Oops. Okay. Okay. Yeah. Go ahead.
Okay. For big data specifically, we have tall arrays and data stores, which can handle a large amount of data. So any big data cannot be sort of loaded locally. So if you're reading the data from cloud service, we have containers on Amazon as well as Azure platforms, where we can interface MATLAB directly with those environment to read data from cloud service as well. And within MATLAB, we have MATLAB data stores and tall arrays, which can handle big data. And MATLAB is quite powerful for big data and data analytics applications as well. So we can share some links at the end of presentation where we can you can for examples on how to handle big data in MATLAB.
Okay. Another question from Bhaskaran. Can you please show the sensor data that is uploaded on ThingSpeak? Is it CSV or TDMS format?
That the data that is uploaded on ThingSpeak in my example here is basically the output of my code. That is, my MATLAB code is returning some output after post processing. So that output I'm uploading on ThingSpeak. So I'm not streaming my entire accelerometer data directly into ThingSpeak. I'm taking it into MATLAB first, and I'm post processing it, and then only the required information is going into ThingSpeak.
Next question.
Data that is going into ThingSpeak is just a number at this point. It's not in any particular file format, but ThingSpeak can read CSV files directly.
Another question from Murugananthan. Is there any development for iOS devices?
Yes, we have interface with iOS devices as well, using the Simulink support package for iOS devices. So it's just like how I mentioned, I'm using Android here, but we have everything, whatever is available here for iOS devices as well.
Suma is asking, we are planning to introduce an IoT lab in our BTech curriculum syllabus. What type of exercises can help the students to get build up knowledge in this area?
Okay, this is great that an institute is looking to use real hardware to teach students. So typically we encourage professors to use hardware devices like phones and Arduino and Raspberry Pi platforms, because these are low-cost hardware platforms which students can use to build fantastic projects. And Naini here has worked with an institute known as KLE Tech to implement this type of learning, which we call as project-based learning, wherein students can make real projects and demo them and show how what they've learned and how they worked to get a project ready. So Naini will sort of add to the points that I'm currently talking on, how she worked with what they did in KLE Tech to use hardware device to build projects.
Yeah, thanks, Pandana. So one thing is it also depends on which semester or which year the course has to be introduced. So depending upon, for example, if it's a final year course, then in that case, we can also leverage the knowledge of MATLAB and Simulink that they have. And but if these are the students from first or second year of engineering, then in that case, we can also just ask them to do the model-based design or make use of Simulink if they are not very much comfortable with coding, and then make use of the hardware support packages which are available with MATLAB and Simulink, and then make directly ThingSpeak based or IoT based applications, which does not actually ask for much coding experience. So that depends upon the level of engineering, or for example, if it's a first year or a final year engineering student, at which level it's going to be introduced.
Particularly, I think KLE Tech implemented this in the first year, and this is a very innovative approach known as project-based learning. And if any institute is willing to try this, please get in touch with us. We have resources and we have examples. We can sort of guide you through how to use MATLAB to implement a project like KLE Tech, what they've done.
Okay. Move on, Spandana.
Yes, sir. Okay, let's move on. So
how much more time you need? 5 minutes or so? 5, 6 minutes, 7 minutes?
Oh yeah, that's all. We're at the end already.
Okay, sure.
Okay, so we've now completed the demo for building an activity tracker using MATLAB and posting the data onto cloud. So what we did here, the first step you need is a ThingSpeak account. So create that using your MathWorks ID, and the MathWorks your ID should have a license for MATLAB. Second, you will need to create the channel and add variables. I showed how that can be done. And if you need more examples and tutorials, we have a web link, which I will share the presentation later, so you can use it to find out what other examples are available. And we support plenty of hardware devices like Arduino, Lego, EV3, and Raspberry Pi, Android devices, Kinect, and so on. So you can make use of this support for building IoT application, and all these devices which can transmit data can communicate with ThingSpeak. We have plenty of examples on how to on our documentation page, so you can find out more examples in our documentation page, and the link for those are given here. So basically, as I said, Internet of Things is a mega trend, and what is enabling Internet of Things is the fact that we have plenty of embedded systems which are now able to transmit data. And these embedded systems also come with plenty of sensors, low-cost sensors, and we have good infrastructure for modeling the sensor networks, their automation and their control algorithms, and we also have machine learning algorithms which can enable IoT. And any internet connected device can communicate with ThingSpeak. Arduino and Raspberry Pi can use their native libraries. And if you're using any local gateways, you can use REST APIs or MQTT APIs. Also, Simulink blocks have ThingSpeak blocks, so you can you drag and drop ThingSpeak read write block into your Simulink environment to post any data onto the cloud. And we have powerful MATLAB analytics integrated within ThingSpeak, and this can enable real-time visualization of data and also perform computations. And you can also build custom visualizations in your data. So we have, if you have any more questions, you can feel free to reach out to us at this email IDs.
Fantastic.
And you can feel free to ask us any more questions. We have, I think, 10
We have
minutes.
a couple of minutes here for many more questions. Let's just check what's going on. Yeah, please feel free to send in a few more questions. We have a little time to do that. Is there any limit in the maximum number of device interfaces?
Maximum number of devices to communicate with what?
I'm not sure. Mugananthan, you want to clarify your question? It just says, is there a limit in maximum device interface? Let's see, what else are other questions coming up? Anything? Just wait for another couple of minutes. Muruganathan, you want to tell us what you mean by that? I didn't quite get that. So yeah, I can unmute you if you want to clarify your question. Your question doesn't seem to be very clear. So, okay, what are IoT applications in electrical engineering?
There are plenty of applications in electrical engineering as well. There is a lot of studies going on into like battery management systems, on how to improve the battery life of a particular system, and for that you need to collect data on how that application is running first. If you're talking about an electric vehicle, for example, the terrain it's the terrain that the vehicle moves on and so on, also the data of that terrain can be used to sort of expand your battery life if well studied. So we also have applications in smart buildings, that is, you can build smart meters for your buildings by sort of getting the data of what kind of, I think this is a big field, and studying human comfort within these buildings to sort of optimize our energy resources. And I think IoT has plenty of applications in smart grid as well. And one more application I can think of is public lighting systems. Like if you can have an IoT device for controlling your street lights, that is sort of very powerful. And I think even now in India, they are being manually operated. So this is one application which can have an immediate impact.
Okay, Muruganathan, you want to come speak up and explain your question, or otherwise we'll just wind up for the day. Okay. All right. Let's see. Medical image processing. Any applications that you can think of? Medical image
Applications in medical image processing.
IoT application, yeah. Mm-hmm.
So, from what I can think of, predominantly, like I think last year in Smart India Hackathon, we sort of gave a problem statement, and that was about how to sort of monitor the spread of an infectious disease in an area, and this was more related to how information and how a disease spreads and how we can collect that information from a primary healthcare center and see how a disease is spreading. This is something that I find very interesting as a medical application. But if you're specifically looking at an image processing application in medical sector, then one thing that I can think of is of course, I mean, deep learning is being widely used these days for sort of labeling and classifying whether a certain tissue or a certain sample is carcinogenic or not. And you can, as soon as you find out if a particular person or particular sample is, you've identified a particular sample to be of cancerous nature, it can sort of send out a signal to start other tests as soon as possible. And I think this is a very critical step, because right now the information transfer from a medical lab to a doctor and to a diagnostic lab takes so much time. So this can be sort of accelerated, and I think this will be a very good application if a diagnostic lab can very quickly send in information about what tests need to be conducted in future, depending on what the output is at that point.
Okay, another question from Hemant. Is there a means to perform data analysis offline if there is a loss of internet connection?
Yes, you can download the ThingSpeak data directly, or you can stream data into MATLAB first and then move it into ThingSpeak. So if there is a loss of internet connection at any point, you can sort of download the data and perform the analysis offline. That facility is available. I can send in more resources in a web link on
Okay.
how that can be done. I think there is an example as well in my presentation.
Okay, so sounds like we have come to the end. I really appreciate your presentation, Spandana, and Naina for helping out. This is fantastic. We've had almost 70 people here and quite a few good questions. So thank you, everybody. Okay, bye.
Thank you. Thank you. Thank you, everyone.
Yeah, bye.
Bye.